few years ago, I installed this floodlight LED ones. I really like them. What I did is I bought two of them, installed one on this side, one on the other side, and I wired the sensor from both of them into one, but to both of them, meaning no matter which direction someone's coming from, both light will turn on. It worked out very well until a couple of months ago. The one on the other side burnt out, and it used to be too bright. So what I did is, instead of buying the same brand, I got a little bit smaller one so it wouldn't be as bright. The problem is, when I rewired the sensors, even though I checked all the outputs, I wired them together, but it burnt out this sensor. So I decided I'm going to upgrade the system again. This was an AC system. I'm going to switch over to DC system so I can use proper relay, because when I looked up the relays for AC, it was more expensive. So I'm going to have three lights now, one somewhere around here, another one exactly there, another one somewhere around on that side, so it can light up the other side, my grill area, and so on. So what I'm going to do is, here's my well, this is a very expensive workstation, but what I did is I bought four of these lights, mainly one for experimenting. I always plan on burning one out while I'm experimenting, but I need three lights, like I mentioned. I will use these sensors and create a circuit, so if any one of the sensors are triggered, all three lights will turn on. Except this time I will use a relay to power all the lights all at the same time, and three diodes to control the power flow. So this way this will never burn out again, mainly for inputs and outputs and wiring. So all the circuits will be isolated, and also use fuse. I will most likely use either a motorcycle battery or a car battery to power all of this, and I'll have a charger system on there. The benefit of that is, if ever electricity goes out, my outdoor lights will still work. As far as the wiring goes, I will show the wiring later when I'm done. I like to install this kind of stuff at night because, you know, it's hot outside and I like to work overnight. But here's I took one of these apart. So this is the, I'm guessing, the power coming in, going right into the sensor, then it's coming out with the red wire, and blue and black is shorted together. So this is the wire I will be cutting and plugging into the diodes, and eventually that will go into the relay, and then that relay output will fit into that circuit. I will show that a little bit later, and I may be doing this overnight tonight. Let's see how this works out. I'm hoping it works out well, and I have to find some circuits now. I mean, the relays and the diodes. So here's what I did to make modify these lights. Light comes like this. They're the DC light, so it works off of a car battery. And once I remove the cover, just those four screws, and it looks like this. Inside that you have this power and ground coming in. Power goes straight to the sensor right here, and then the red wire powers the circuit, which powers the light. So what I did is, I'll get rid of this. What I did is I cut that wire out completely. I replaced it with four wires. It used to get power and ground. So now what's going to happen is, it's a little bit hard to see, but the power with the black wire goes straight to the light, so it doesn't go through the sensor. And the red wire is the power that goes into the sensor right here, and the output from the sensor goes into the white wire, which comes out this way. and on this side I will do the diode and the relay, so that way the power from the relay will go into the black wire, which will power the LED. So there will be two power coming in, one ground coming in, and one sensor coming out. So originally it's going to get power and ground from the sensor, but the ground is split internally and goes into the sensor itself, so I don't have to bring two grounds. Power and ground goes to the sensor. Sensor will trigger, it will come out through the wire, and then I will have some logic with all three lights. Then from a relay, power is going to come out and go into all three of the lights at the same time. So any one of the sensors will trigger all three of these lights all at the same time. So it'll be in three different locations around my garage, and no matter which direction someone comes from, it will turn the light on, all of them. On this one, I only twisted the wires and shrink tubed it, but because this wire was, the red wire was so short here, I didn't have any choice. I had to use my soldering iron and solder that on there, because not enough length for me to twist wires. And I used heat shrink tube with the glue in it. This is better, that's easier. I prefer not to use solder as much as I can, but sometimes you just gotta use it. So here's the diodes, and here's the diode model. The diodes, the wires I'll be using, the relay, and the switch. Let me wire them up and explain to you why I have all of these things on here. Here's what I did with the diode. Let me get this out of the way. Okay. So once it focuses, the diodes are directional. So I cut them short and I soldered it with the wire with different colors. The purpose of different color is so I know the polarity of the diode. In this direction, let me see if I can zoom in a little bit better. In this direction, the input will be the white wire and the output will be the red wire. So after I do that, I wrapped it with the shrink tube, so it protects the diode and all the circuits. By that I mean soldering. And after I'm done with that, this way I know the polarity of the diodes. So what's going to happen is, on this end, the output from these lights, these I don't know why it's focusing like that. Output of these lights, the white wire will be coming into this white wire, and the red wires will be going into the relay's white wire, and black going to the ground. So this will be used to trigger the relay, and for the relay, this will trigger the 12 volt. So I'm using a 12 volt to trigger a 12 volt. The difference is this will be the sensor's input, this will be output to the LED lights. And I have 3 lights, but I have 4 diodes. What I'm going to do is I'm going to twist all of these red wires and tie it to that white wire of the relay. This way I can have all 4 input going in there. So 3 lights, output from 3 sensors, and I will have a switch here. What I'm going to do is short that to 12 volt. That will override all the sensors and turn on the lights. So let's say I'm doing grilling or something and it's getting dark outside. All I have to do is hit this switch and all the lights will come on. This way I'm not going to be in the mercy of the sensors, because that's very annoying when it keep turning off and I have to move for the light to come back on. So I'm just going to override it. One more thing about the diodes, I could have just short all the wires together without using the diode, but the important part about the diode is what most people don't know, well, if they didn't take engineering classes, is once one of the diode triggers, all the other ones will stay open. So even if you put 12 volt in all 4 wires all at the same time, only one of the diode will be closed circuit, leaving the other ones open, because unlike resistors, you can't put diodes in parallel. You could put 100 of these diodes in parallel, but only one will work at one time. So that's the beauty of it. This way I keep all the circuits isolated. All right, moving on to the next step. There we go, the relay is ready. Well, just one circuit. This is going to the ground, as I mentioned, and all the sensors are coming into that. So any input from any of these wires will trigger that relay. I want to mount this battery, which is about 1 foot long, maybe a little bit more, up on the wall, way up there. So I could use a lot of brackets to make a shelf, but I'm going to make a shelf out of this piece of wood. It will go on like this, and what I did is I have some extra on this side, extra on the other side. I got screw from this stud and that stud from outside. In addition to that, I made a hole here and there, so I can screw from this side as well, which it will give all the support it needs. I don't need any metal bracket, I don't need anything else, just 4 screws will do the job. I may put a couple of extras just for fun, but all I need is 2 on the side and 2 on through those holes, and that will hold the weight of that battery. The shelf is in place, battery is on top. I tilted the shelf a little bit inward, slanted this way, so if there's like an earthquake or something, this is going to go against the wall and not fall out. I may still put a bracket on there just to hold it, but I don't really need to. It's on there very securely. This is not going to fall. So most of the work is done, and now I can install the lights. I just finished making the harness, but wait. At first look, it's gonna look a little confusing, but give it a second. This is nothing compared to what goes in a car. So let me start with the ground. It's very simple. It goes to negative terminal of the battery, and all I did is split into 4 wires. What that's going to do is going to take negative side to all the lights, and negative side for the charging unit. That's it. This one is the simplest thing, just some splitters. Let's put that aside. Now let's talk about the relay. Relay is going to be triggered by those diodes, the sensors. This is going to one of the wires for the ground, and this is going to one of the powers coming out of the positive terminal, and this will go out to the LED lights. So let's put that aside. Here is the positive terminal that goes to the battery. This also has splitters, but I have fuses in line because I want to protect the wires. This one, actually start with this one. This one is going to be, I'm thinking 3 amp. This will only power the sensors. So these powers will go to different sensors. I will have 4 sensors going to 2 wires and 1 extra in case I ever want to add any more. So with that aside, let's talk about this positive side. This is the high power side. I'll put 10 amp. There's 3 LED lights, and I think they're 30 watt each, so they should pull roughly 3 amps each, so they shouldn't pull any more than 10 amps, and the wires can handle over 10 amps, so I'm just going to put 10 amps. So if there's any short circuit in the wires. It'll burn out the fuse, not set my garage on fire. I also have on the other side the protected fuse, this little connector. This will be used to charge my Noco 70. That's a jump start kit. So this way I don't have to hook up another adapter. I'm just going to power right off of the battery. So that has nothing to do with the lighting system. This wire is, this one's going to one of the grounds, but this wire is going to be in the future if I want to use a solar panel to charge the battery instead of plugging into the wall. And on this side is the actual charger. I guess you want to say inverter or power adapter that will take the AC, convert to DC, and charge my battery. Keep the battery always charged so it always works. Other than that, I have some extra splitters just in case I want to tap into something. That's it, keeping it very simple. So I have plenty of splitters. Now I'm just going to start hooking up my lights, which I already mounted on the wall. For the moment, I only have 2 lights connected. As you can see, with the charger plugged in, it's plugged into there, and only 2 lights connected, 2 signals input, still waiting for 2 more. Voltage is 1264. Let's go turn on the lights, see what it looks like. Here are the lights. They are both on as planned. Let's see what happens to the voltage. It's dropping just as expected, and as soon as the light turns off, I think it's about 10-second timer. Let's wait for it. I think it turned off and the voltage is going back up. I think you heard the relay click. So this is going to be a balancing game between the charger charging the battery and the LEDs draining the battery. Let's see how it goes. This is how I am wiring the switch. I soldered this pin, that pin, covered with shrink wrap, then I'm going to cover the whole thing with shrink wrap, then I'm going to put it into the wall. Alright, let's take a few quick measurement on current. I'm going to use this current measuring device. Total power coming out of the battery while being used is 4.7. Total power being used by all the lights, 3 of the lights, are 5.4. That's because the charger is actually charging. Let's see if we can go into this with one hand. 0.9, so almost 1 amp. And if we measure the ground, should be about the same, 4.7, 4.69. The sensors are pulling almost no current. So what that means is the charger is charging about 1 amp hour, and it's draining about 5.5 amp hour, and it can charge all day, and it will work up on the battery. That's with all 3 lights on. It's raining outside right now and it's dark. The sensors are not triggered and the sensors have a delay, but I'm going to show the effectiveness of the switch. Switch on, switch off. So I'm controlling the lights with the switch. I can't show you from outside because as soon as I go outside, the sensors will trigger and the switch will be useless basically. On, off. Finally clean up the mess a little and hang it on the wall. Here the wires coming, just crow's nest of wires, and everything works fine, and I'm just going to tuck the charger in right next to the battery. That's it. Now the whole system works. I have a friend who wants me to wire his brand new house and put lights all around it. I'm thinking I'm gonna make a system with 10 lights and 10 sensors and maybe a couple of switches. But this works well. And one car battery is enough for this. And I may add a solar panel. All right, good luck.